Hello everyone and welcome to today's webinar, Combining Cores with 3D Printing. We'll start the webinar in approximately 2 minutes while everyone filters into the room. Okay, good morning and welcome to today's webinar, Combining Cores with 3D Printing, brought to you by ExOne. I am Shannon Wetzel, Managing Editor of Modern Casting, and I'm excited for this webinar, which will offer some real-world insight into 3D printing from Prospect Foundry. First, we'll go through a couple of housekeeping items. This webinar will be recorded and made available to today's attendees. You will receive an email with the link to the recording within a week after the webinar. Second, the presenters will be answering questions at the end of this session. You can type your questions in at any time during the webinar in the question box in your control panel, which we have shown here. Now let me introduce you to our speakers. We have Terry Sanish, Director of Technology Applications at ExOne, along with Greg Calissimo, Metallurgical Engineer for Prospect Foundry, and Bob Greedle, Quality Manager at Prospect Foundry. Greg and Bob have a combined 80 years of experience in the metal casting industry. So thank you again for attending today's webinar, and now I will pass it off to Terry to get us started.
All right. Thank you very much, Shannon. I appreciate it. And again, thank you, Greg and Bob, for certainly allowing us to present your story here of your experience with 3D printed molds and cores. But before we start here, I'd certainly like to mention often at ExOne we get asked, what does it cost to 3D print a mold or a core? And sometimes a customer will show us a picture or a part, and generally we'll respond in some sort of cost per cubic inch, and they may do a quick calculation in their mind and say, okay, well, you know what, it sounds like you're more expensive, and you know, unfortunately, we're disqualified before they even get a chance to see the actual downstream benefits of 3D printed cores, and so often when a foundry implements more traditional approach and maybe running into problems or issues, it can be viewed as, well, you know what, those are just typical problems and issues that we see, and the scrap rate is a little higher, so let's just continue and proceed down the road, when they really didn't even get a chance to really see the downstream benefits of 3D printing. So really, you know, when you're saying how much does a core cost, you can also ask yourself, what does it cost not to have 3D printed cores or molds implemented in your process? And to set the stage here, what I'd like to do is just talk about a real-world scenario with our customer, Prospect Foundry. And but basically, if we roll back probably a good 3 years or so, there was a customer that was looking to produce a gray iron casting of a hydraulic spool or casting that they're looking to produce, and it had some pretty complex internal features in it. So certainly the customer contracted the foundry to produce the casting for them, and unfortunately, after repeated failures and limited or no acceptable castings, certainly the customer is obviously a big concern now, and becomes late with their customers. So they have to make a decision here to to get their parts in time. So unfortunately, or fortunately, however you want to look at it, from Prospect Foundry's eyes, or the customer's initial foundry's eyes, they pull the job from the customer and from the foundry and give it to Foundry B, and Foundry B happens to be Prospect Foundry. At this point, with Greg and Bob, certainly join in at any time here. But at this point, with number 5 here on the list here, you guys are under a bit of pressure right now, right? So you have time constraints that are looking to be met, and certainly in the end of this whole thing, you ultimately end up reducing your scrap rate using more of a traditional approach, where the scrap rate was around 70%. Down to about 5% as you guys get rolling with 3D printing. And that seems like a pretty significant reduction in scrap from what we can see here. So tell you what, Bob and Greg, I'll let you go ahead and talk about the core here and what we're dealing with and what type of problems and issues and concerns you might have had initially, maybe when you were looking at this for quoting. And I'll let you guys take it from here.
Okay. Good morning. This is Bob Greedle from Prospect. And originally, we received this design, this part number, and we started making castings. And we had a lot of problems with trapped gas and blow scrap on this job, as Terry mentioned. So we tried numerous tests, trying different things with venting and gating systems, pouring temperatures, pouring times, etc., and with limited success. On top of that, just as you look at these cores, there are 4 separate cores that are made and then assembled together. So there's quite a bit of time in producing the cores, assembling the cores, drilling the cores, dipping the cores, mudding the seams for assembling the 4 pieces together. Very time consuming, very high in cost. And then just to turn around and scrap 50 to 70% of those castings every time was just driving the part further and further. It made us realize why the previous foundry was no longer trying to produce the part. So
you guys were aware that you'd probably be running into some alignment issues and things like that, probably when you initially started looking at this core. I would assume with your experience, if we take a look a little deeper here.
Right, yeah. And with assembling 4 separate pieces of the core together, you have some variation dimensionally. And so Greg started doing some research and came upon your process here.
Well, actually, first of all, this is Greg Colosimo. We tried several different traditional type methods. We used ceramic type sand on the shell machine. We tried zircon sand on the shell machine. And we tried different coatings, alcohol-based and water-based, and some mullite, aluminum. We tried zircon-based wash. We did just about everything in the book. And some of the problem that we had was that the paste in the joints would swell and cause misalignment. So even if we did get the part right, it wasn't always lined up perfectly, and the customer had to reject them because they couldn't drill the holes properly.
Yes, I mean, if we look at the core, I mean, certainly it's a quality pattern-making job that you guys had done here. But like you said, as you're adding, core paste and wash, you guys are running into some issues down the road.
Right, and keep in mind, these guys were doing 400 to 800 pieces at a time. So you had multiple guys on different shifts, third shift, second shift, first shift, all different people. And different guys have different work habits, or they have different technique. That's what it is. Yeah. And right. Where one might make a perfect core, the next one might make a just about perfect core, but the measurement of how much they were off is almost indiscernible by the eye. You'd have to measure it with a micrometer to see. So
there was some variation there, and that's normal. No matter how well the core box and pattern are made, you're going to have some variation. And with the 3D printed cores, we've taken that variation out. We've also taken out the need to produce 4 cores and assemble 4 cores and handle 4 cores. The getting one core that is virtually identical time after time, core after core, was fantastic. And we also passed this information along to our customer, who they were very pleased with our looking into this process, and from a repeatability standpoint, from a dimensional repeatability standpoint. So it wasn't something that we were trying to hide from our customer. We wanted to be very open about it, explain to them the benefits of it, and they were very pleased with that also.
Right.
One of the other benefits, the big benefit that I saw from my point of view, was that the shell sand has a 2.7 to 3.4% resin, whereas the printed core is just over 1%, so it was a lot less gas being generated.
So again, looking at this a more traditional core here that's been pasted together, you had mentioned about all the different, I guess, idiosyncrasies that can happen here, and certainly the glue has to be dry as well too, right? From a pasting perspective. So you guys are almost making it sound like there's more than one way to screw up a casting, right?
Absolutely.
Yeah.
Yeah.
Absolutely.
Wow. So now, again, once you start with your traditional approach here, and you set these cores in the mold, and you guys are probably under a little bit more pressure right now to get this done from your customer, because he's still late, isn't he? So.
Correct, and that was the other thing, the timing to go through all of the, it was a hot item with the customer because of the lack of success from the previous foundry. So we were kind of under the gun from day one, and then finding all the issues and all the problems, and just having enough time to produce and assemble, as I mentioned, all the cores, just put a tremendous amount of pressure on us. And as you'll see in some future slides that you have here, the problem with the castings, all the trapped gas that was in there, and Greg related to that. There you go. That's some of our earlier castings that we made with our cores, and all the gas that was generated, because you're pouring iron 2,600 degrees into a sand mold and surrounding that small little core with all this molten metal, you're creating gas, and that gas has to go somewhere. So if with ExOne's process, in discussions with Greg, between the two companies, we came up with the best solution, the best type of core sand to really pinpoint and eliminate our main problem that we had.
Right. So again, Foundry A, who obviously went about this in a more traditional way, using traditional patterns. Again, when it got turned over to you guys, Foundry B, or Prospect Foundry, again, your initial knee-jerk reaction was to go about it in a traditional way, to say, hey, let's just create our patterns and move forward. So as far as even considering 3D printing early on, it was really not in the front of your mind to really pull that wild card out yet, wasn't it? It wasn't until
That's correct.
You guys had to go outside and find some additional solutions here, in a little bit of a panic, I would assume.
Not quite a panic, but you're on the right path.
Yeah, when I went to the AFS regional in 2015, one of my key job there was to find some kind of way to fix this problem. And I talked with a lot of vendors about core coatings and about non-traditional types of sand media, well, a replacement for sand media, you know, to create the shell sand for the to make the core out of. And these were very expensive solutions, and I couldn't see that it was going to create something that was very much different from what we already had. And then I talked with the gentleman at the booth at ExOne, and when we finally got around to the point of finding out how much it would cost to make these cores, and compared to our limited success, plus all the work that we put into it, we found that it was actually cheaper to get the cores printed. It costs us less.
Right, and that's not even including all the hidden costs and all the other potential lost confidence from your customer, potential new work because you can solve their problem. I could go on and on about that.
Right. So basically, if I recall correctly, at the trade show, which again was just a mini regional show up in Wisconsin, when you had stopped by,
Right.
I believe we had a sample core on the desk, and you said, "Boy, I wish you could print 1,000 of these for us," right? And,
Exactly, that was right.
yeah. So
and, you actually said, "Yeah, we can do that for you."
yeah. So what, you made a phone call right there at the foundry to your shop to see if you can combine some cores, right?
Well, our foundry engineer had to put together the model for the core, and basically what he did was he got the model that they used for the shell boxes, and he combined those. He got the core prints off of those, and then he stripped away the metal part of the casting and came up with the inside passageways, and he combined them together and made the actual core model.
The model that you currently see on the computer screen.
Yeah, that's that model right there. And I had that sent from the foundry to ExOne, and they said, "Yeah, we can make this for you." And they started on the samples. I think we sampled 4 different types of resin and sand, and we finally arrived at the best solution with the help of the team at ExOne. And from that point on, we actually thought we were going to lose money in 2015 because of this job, but we actually ended up just about breaking even. And then the next 2 years after, we've done very well with this part, very well.
And the benefit for getting the different cores, you know, it's the same core, but the different processes, the different types of sand or the amount of resin. The reason that's important is because different part numbers, different foundries, and different part numbers in those foundries, you might be fighting a different animal. Are you fighting an animal where the assembly time is killing you, or are you fighting the enemy that the trapped gas is killing you, or some other thing? So maybe or the cores are breaking, or et cetera. You could go on. In this case, it was not only the assembly time, but the LOI and the trapped gas in the mold. So we really got a double punch, a good double punch of saving time on assembly and improving that LOI so that we reduce the amount of gas that created in the mold in the first place. And, you know, it's just a win-win on both situations. So, you know, one type of core across the board isn't, you know, it's good to test different things, maybe, is the point of that.
Right. So when we run these cores over at ExOne, and again, we've printed thousands of cores for you guys at Prospect for quite some time. That a couple things. Again, we've kind of initially solidified on the furan and silica option, which worked out well, and you guys applied an alcohol core wash to that, which appeared to work best out of the different sands that we have tested and binders. But I think you know, ultimately what people should understand too, that from a our ExOne adoption centers, we certainly do our best to maintain high quality cores as well too, and those that have machines certainly try to do the same, obviously. But one big thing is the 50% humidity that we try to lock in our shop here, plus or minus a few points here, but nonetheless, that allows us to use a consistent amount of binder and activator throughout the year, and have lower LOI, higher strength, and as you had mentioned, Greg, your LOI was what initially with the traditional cores?
Right, we had over 3% LOI with the traditional cores. And Terry, we don't have problems at Prospect making cores. We have 14 shell machines. We have ABC set up, and we also have Furan for larger cores. So, we're very proud of our ability to make difficult cores. So it wasn't like we had one hard one that we ran to look for a solution, but this one just wouldn't fit. And
right.
For people that have shell machines, they know that sometimes there's cores that have what they call false fill, and it's when you get a layer of sand on the outside, and it's just a thin layer, and it collapses when they pour the metal in, and then you get a scrap casting. Well, that's another thing I was thinking of, that 3D printing would cure that, because we have a couple jobs that we might be looking at where we have this problem of false fill, and it takes extra time because they all have to be checked and patched and then recoated to go before they go into the mold. And that's another thing that 3D printing could easily fix.
That's a good point.
Right. No, that's again. There's a lot of things. I think a lot of customers, if there is even a slightly higher scrap rate of anything, and again, there's a certain amount that's considered normal to the industry, and certainly some experimentation with 3D printing, may find some downstream benefits that normally you would not normally see or uncover. But one of the biggest things is shipping is generally not our friend when it comes to 3D printed molds and cores, and so we've gotten very good at it over the time. And I know you had mentioned that our initial packing strategy was not as efficient as what we do today, but certainly we've gotten good at shipping cores over the years. And if cores are too lacy, what we can do is ship them in a box with loose sand in there to help support the core during the shipment process. So it sounds like, though, with everything that you guys have received, though, you guys have been pretty happy from a shipping standpoint.
Absolutely. This particular core, as small in diameter as the passages are, is about as fragile as you can get. You've got big, heavy core prints on the end, and then you have all these 1/4 inch, or actually slightly below a 1/4 inch passages running through this thing. They're very susceptible to cracking and breaking. And the packaging that you send them in is fantastic. We very seldom see a cracked or broken core. And, we also run our own LOI test here at Prospect. So if we don't find a cracked or broken one in the box, we end up breaking one ourselves just so we could run our internal test.
That's right. And that's one thing that's been from day one since the first shipment. There might have been a lot of foam in there, but we didn't see any broken cores. And that was one of our initial worries, that when we talked about ordering these, the guys in the office are saying, well, how are they going to ship these cores without breaking them? Because we bought larger cores from other vendors, and when they arrive, they've rubbed against one another or in some way broken. And so that was a major worry when we first purchased the cores from ExOne, but we haven't had a single time yet when we've had broken cores in the boxes.
It was worry that was not needed.
Oh, great. No, that's good to hear. Yeah, I guess you're right. Whether it's a traditional blown core or a 3D printed core, they certainly got to ship them and get them there in one piece. So this is kind of showing your foundry there and the finished part that you produced here. So it sounds like your customer has been pretty happy here when it comes to the castings that you've been delivering.
A success story, no doubt that it solved our problem and it made our customer happy, and it turned a losing job into a winner.
Right. I think we've made over 3,000 castings this year so far in September. So we'll see. We might hit 4,000.
Great. Yeah. No, that is excellent, and certainly that the question, what does it cost not to have 3D printing, and certainly you can try to assign a dollar value to that, but what do you guys suppose Foundry A initially that got the job pulled from them is thinking? I know you had mentioned that you don't want to be that guy, right, when it comes to a foundry that could not deliver, right, and just curious how you guys.
Well, if you look at what does it cost, let's just start from the beginning. What is it? First, you have to rig the tooling to run in your shop, and that costs a few $1,000s to get the gating system and pattern ready to rig, ready to run. And then if you run a test, you break into production on whatever molding line you're on, and you run your samples. It probably costs anywhere from $1,500 to $2,500, depending on what the machine is, just to run that test, to process the samples, and then to have the people cut up those samples, inspect them, et cetera, et cetera. So say you run 5, 6, 7, 10 different tests, and you're still struggling with this job, just on an average figure, that's a $2,000 bill every time you're doing that. So there's a lot of lost revenue. And you could be producing something that you could sell to a customer at that same time you're running these tests that are failing. So there's a lot of money there. And then just the frustration of it all, and dealing with your customer as we mentioned, and trying to make promises based on when you think you can get this job up and running, and it leads to a lot of lost revenue that you can put your hands on. And what does it cost not to have it? Well, that's that great unknown that you really can't put your hand on it, because you don't know how your customer is going to react. They may be happy that you're trying to help them with a known problem job that's already failed somewhere else. But at the same time, if you solve the problem, they're like, hey, great, these guys figured it out. They know what they're doing there. We need to get more work into their foundry. So that's that terrific thing that you don't know. But if you don't get it, you'll never know. If you do get it, you can measure it, because you can, you just measure your increased sales dollars with that customer, and there's your success. What I can tell you on this particular part number is that, the first year we were looking at, around $46,000 in sales. Well, it's gone up since then. This year alone, we're at $138,000 in sales on this one part number. And, that's just one part number. So the fact that it's profitable for us, and it's economical for us to do it. Getting the cores produced by ExOne, transporting them to us, and getting them to the molding line is economical. It works. It's repeatable, and our customer couldn't be happier with the product that we're shipping to them.
And another foundry might be saying, hey, we could have thought of that, but they didn't think of it.
Right. No, again, I think you know, is 3D printing, you know, great for every application, you know, from a cost perspective. You know, no, there are times when it can be, you know, a question, but nonetheless, you know, when you guys are, and foundries in general, when they're running into some problems, certainly, you know, it's often worth testing and trying 3D printed cores, because some of the downstream benefits, what we see in other industries, since for instance the pump industry, that with one-piece impeller cores, what they're able to do is reduce the vane spacing and tolerance stack up, and eliminate downstream balancing issues, and have better performing pumps that arrive at foundries. And again, a lot of these things, unless you experience it, you know, it's something that's often overlooked, I think, moving forward. But yeah, so again, Greg and Bob, I again appreciate you sharing your success with this, and certainly, you know, I think what we can do is open up to questions for anyone that would have questions for myself, for Greg or Bob at Prospect Foundry for this, you know, 3D printing topic.
All right, thanks, guys. And yes, everyone, please feel free to type in your questions now. There's still some time. And while you're doing that, we do have a couple questions in already. But first, you know, Greg and Bob, this was, I believe, your first time incorporating the 3D printing. And kind of what was the learning curve? Did you run into any hidden costs? Did you have to learn how to handle the cores differently? Maybe you can talk a little bit about that.
Not a lot of learning curve once we got the cores in. The main thing that we considered was drilling. Every foundryman knows that you can't vent the cores or the mold too much. So, you know, our concern was we were venting the cores a lot with our process. So the question was, well, are we going to need to drill these cores as much, or in the same places, or that? So, but it was very little, and
we didn't have to.
No, we ended up trying some, but we really saw no benefit from adding more work to the cores that we were receiving. So there really was very, very little learning curve once those cores were received here, and we were all pleasantly shocked, if you will, on the very first time that we put these cores in the sand, and with the results that we received or ended up with.
You know, I think that the gentleman in the core room, upon first receiving these cores, they set up a few guys that would unpack the cores and get them ready for production. And probably the first few times it was a little bit, you know, a little bit rocky. But now that they've gotten into it, they can unpack 200 cores and get them ready in a matter of a few hours. And that would have been a process that took them days before. In fact, you know, ExOne has been excellent with the service, and their on-time delivery helps us incredibly because we're able to plan around the deliveries really well.
All right, thank you. Now, how long did it take to break even? And when you started seeing the cost savings, where did that come about? Was that in just the cost of the cores? Was it in production? Was it in saved time?
Really, all of the above. Just in the producing the cores, handling the cores, definning the cores, assembling the cores, mudding, dipping, all of that was a huge savings. And just in what we measured as best we could, and we feel that in the first year that we saved about $27,000 just in the production of the cores.
Thank you. We're also getting a few questions about the size sand or the GFN used to print this core, and then also just the kind of the size range ability of the machine for printed cores. So I don't know if the Secretary...
Yeah, I guess I could answer that one there. But the GFN or grain fineness that we use for these particular cores was 83 GFN silica sand with the furan binder. And as far as the core size, the S-Max 3D printers that we have at our ExOne adoption centers, both in the Detroit area and also the Houston area, they are capable of printing 70 inches by 39 by 27 inch build chambers. So basically as one piece, it would be 70 inches and in length. Now again, if you're talking about a mold and how big of a mold can be printed, certainly a casting can be 50 feet long, and we can create a combined core structure, combined 3D puzzle mold to create a very, very large mold. So generally, we don't see too big of a limit when it comes to size. But certainly, you know, at that point, looking at other processes as well too, whether it's styrofoam or you know, other approaches to produce some patterns may have its cost benefits as well too once you get above a certain size. But nonetheless, generally there's nothing that we can't print from a size perspective, but any one piece will be no longer than 70 inches coming from an ExOne adoption center or one of our customers that have a 3D printer.
Okay, thank you. A few questions about just using the cores in production. One, did you experience any core breakage during the pouring process? And if so, how did you correct the issue? Another one was talking about if it was a different or more difficult in the shakeout process.
As far as core breakage, I would say just the opposite. That this particular job, because the cores are so small, the passages are so small, that we have chaplets on this particular job, and with the assembly of 4 cores being put together and the variation, we were having more core breakage because of that variable. With the ExOne cores and the repeatability from a dimensional standpoint, the core breakage went down to next to nothing because the chaplets would kiss. The repeatability of the chaplets kissing the core was there time after time, so it actually core breakage was reduced. So,
and on shakeout, one of the problems that we also had besides the gas was burn-in on the shell core. And that was eliminated by the using the furan sand with the alcohol-based graphite core coating. See the lands, the round little hoops on each core as it goes from one end to the other, those were getting burned in on the traditional shell. And once we got to this lighter material and with the graphite wash, it was able to make a barrier where it didn't burn in, and they shook out. If there was extra sand left in there, they'd tap it with a hammer and it would all fall out.
Right, it's another one of those hidden costs that you save over in your cleaning room, because as you can imagine, any hydraulic valve has to go through a valve inspection process where it's inspected with lights and borescopes. And as Greg mentioned, if there is some burn-in, iron penetration into the core, that has to be cleaned out over in the cleaning room. And in some cases, if it's severe enough and they can't clean it out, the casting's scrap. So as Greg mentioned, with the furan sand from ExOne, we have very, very little burn-in and iron penetration.
Great, now let's move on to the core coating and core wash. Do you use a core wash? Does ExOne provide the cores with that applied already?
No. That was something that we did at the foundry after we unpacked the cores. And we have several different types of core coatings there. So on this particular one, they dip it in a dip tank that runs a continuous mixer, and it was graphite based. That was the first method. And once we realized that the water was causing too much the water-based coating was causing too many problems, it was burning in. We used the alcohol because it would not add any moisture to the core. And so we allowed them to air dry, and they dried really fast with the alcohol-based core coating. And they didn't leave behind any moisture.
Yeah. So at ExOne, we typically do not ship cores with coating on them. However, because in general, foundries generally have the preferred coating process that they would like to see used at their facility. And again, whether it's water-based or alcohol-based, it's foundry preference. As far as the cores and what they can withstand, using our furan-based binder, we can use either water-based or alcohol-based core washes. And again, it's mainly foundry preference.
And what about the sand testing? Is that done at the foundry or at ExOne?
Right. So as far as I can speak, at least when the cores leave ExOne, again, what additional testing Greg and Bob have done. Again, of course, they've done some sidebar stuff that they've tested it as well too. But typically when it leaves our shop, what we do is we print test bars and permeability pucks as well as LOI tokens. So in that 70-inch by 39 by 27-inch build chamber, we fit as many cores as we can to 3D print all at once. And in between those cores, we will put roughly a 1-inch by 1-inch by 6-inch test bar. It's actually a metric size. And then also some 50-millimeter cylinders for permeability. And we'll actually measure, weigh, and break each test bar to make sure it falls within a standard strength and dimensional attributes that we expect to see from our 3D printers. And then also permeability is tested, so we can look to see the permeability or the breathability of the core itself, which is the standard factor that we look for, as well as the LOI or loss at ignition, which typically we're at 1.3 to 1.4% with the furan silica system. And I know Greg and Bob, when they get the cores in, again, we can supply the data sheets for this. We can also supply test tokens, like if somebody wanted dog bones. That could be something that can be 3D printed in our machine, and we can supply that to customers that if they want to test it on their own equipment, they can certainly do that. But I don't know, Greg and Bob, if there's any additional testing that you did on your site other than the ones you mentioned.
Just LOI. And we found our results to be very similar with yours.
And it's really up to, I guess, any foundry's discretion whether they're going to check incoming product that they purchase, in this case, cores from ExOne. But as far as prospect goes, yes, we like to check it also just to see what our numbers are.
Great, thank you. What about the shelf life of a printed core? How does that compare to the other typical cores you're using?
Actually, good question. You know what? I'm going to start by letting Greg and Bob maybe answer that from their perspective on what they've seen, and then I'll chime in after the fact. But because we've had apparently this discussion a while ago, but I'll let you guys talk about your ordering process and how many you order and what you found in the past first.
Well, on our ordering process, we found that at first we used to order 200 at a time. And the first time we ordered 1,000 pieces, we had them sitting around for 4 weeks. And the last run, we had some scrap. It was like higher than we'd had in any of the previous runs. And we thought it might have traced back to the cores sitting around for too long, but eventually we realized it was a problem with the molding machine. And so I think we've gone back to that where we order, and typically our cores will sit here. They have a shelf life here before we run them 2 to 4 weeks. But I imagine they would probably go a lot longer than that. Actually, they don't appear to lose strength at least the furan. Now, if you have a different type of resin,
Cold box,
I couldn't address that, but
like a ABC or
I don't.
Set.
Yeah, like Pep Set. I'm not sure what the shelf life would be on that. The furan is a strong resin, and it hangs together quite well over time.
very similar to the shelf life of a shell core,
Yeah, which is
many months.
Right. So yeah, no, I appreciate that, Greg and Bob, for mentioning that. And certainly coming from your mouth, means a lot more than coming from the salespeople, right? But what we have found and observed is that the shelf life of our furan molds and cores is actually very, very long. We've cast cores that have been sitting around for 6+ months, and as long as it's in a cool, dry environment, there is, a little bit of a chromophoric reaction to where the cores, which are normally green right out of the machine, they can have a little bit of a yellowish tint, which is typical when the UV light hits the cores over a period of time. However, it doesn't affect the actual castability of the cores. We've found that they perform just as good, even though they may appear a bit discolored compared to fresh out of the machine in its dark green state. So for the most part, we really haven't seen any shelf life issues. In the 9 years that I've worked for ExOne, I've never had an issue with that. Not often do you have cores sitting around for years and years, and not saying that you couldn't, but by all means, everything by customer's choice can be stored digitally, or we can destroy the data afterwards. But it's not uncommon for a customer to call us 2 years, 3 years down the road and say, hey, I need 2 more of this part number. And if it's on our server, which we'll retain it as long as the customer wants us to, and we can reprint those cores from as needed. So typically shelf life is not really ever an issue, or hasn't been, at least in the 9 years that I've worked for ExOne.
And Terry, you did bring up a very important point: the environment that you keep the cores in, and also, obviously the drier environment that you can keep them in, the better. And Mother Nature has a role in that too. How humid is it? Is it 20 below zero today, or is it 100-degree heat index out there? Summer versus winter. So that's something that can play a role. So, but
right. Yeah, no, it's a good point. And like you had indicated earlier, that furan is generally not a hydroscopic material where it just wants to suck in moisture compared to more the silicon type binder systems. So yeah, as long as it's, again, reasonable shop environment, you're going to be fine. And we know that humidity can fluctuate within the foundry a good amount, but generally, unless that core physically gets wet, gets rained on, or gets spritzed with water, you're not going to see a problem. And if you suspect anything, generally putting it in an oven at a low temperature, or anywhere between 125 to 212 degrees for a certain duration of time, you can drive out any moisture that you suspect could be in the core. But for the most part, we haven't seen any issues with shelf life and degradation over time in general.
Okay, I think we have time for 2 quick questions. Well, we'll see how quick they are, but I think we've got time for 2 more. First is, how did the cycle time of the conventional core production and assembly compare to the cycle time of printing, extracting, and setting the core?
Well,
so yeah, go ahead, Bob.
Yeah, I'll start with this. Every casting has its own personality. This particular, personality and geometry, and how many cores, is it just a single core? In this case, it was 4 separate cores that had to be put together. So the cycle time, if you will, of producing one solid core for us versus ExOne's ability to create that one core, has got to be astronomical difference.
we couldn't ever match them.
We couldn't even come close to not only the accuracy, but just the speed in which it's done. I guess I'll let you take from there, Terry, on how long it
Yeah.
takes for one of these
No,
cores.
that's great information. And from a printing perspective, basically, if you can picture that 70-inch by 39 by 27-inch build chamber, our typical layer thickness is 0.28 millimeters, or approximately 11,000ths of an inch. That job box stuffed with cores, as many as you can fit in there, you're looking at 18-hour build time, 18, 20-hour tops build time to produce that full job box of cores. So that could be several months worth of cores that a foundry like Prospect may need that we can produce. So certainly doing them in batches not only works for the foundry, so they don't have them sitting around where they can get hit by a high-low or run over or just in the way, but it also helps ExOne in regards to just doing batches, and we can dedicate resources to cleaning and packaging those cores in a more I guess homogeneous fashion than trying to get them all done by the end of the week, and then they're going to sit at the foundry for several weeks before they're even inserted into a mold or tool. So yeah, as far as print speed, we have and again, that's one machine to do. Who knows how many we can fit in the job box? My guess would be several hundred, maybe even pushing 1,000 of these that could be printed overnight. But having 3 machines at the ExOne Adoption Center in Troy and several in their Houston facility, as well as again customers that have purchased ExOne 3D printers, they all have the capability of printing at the same rate.
Great. Now, final question is for Bob and Greg. Where do you see this going in the future for Prospect? Do you have other projects in the works that might be using this, or can you see other instances that will be used?
My answer, yes. I would say definitely we could see the value of using ExOne on other jobs. Do I have any right offhand that I could name? There is one that we've been discussing lately, and we're certainly opened our eyes up to a new way of resolving problems. Let's put it that way. So
the one big problem that is the obstacle, if you will, is having that 3D model of the part, which you have to either have someone that's capable of doing that computer work at your shop, or someone you can send it to who can make an accurate, exact model of the core. And we have this one job that we've been discussing for a while, getting 3D cores printed, but we haven't gotten to the point of making the model yet. Once I can convince everyone to make the model, then, once we get the model produced, then I think we'll be sending that down to them.
Yeah, and keep in mind, when you make the model, it's not just the internal features of the casting. You have to create the core prints also. And those core prints that you put on your model need to match very close to the core prints on your pattern, so that you do, in fact, have that repeatability of how that core locks in the mold time after time after time. Because once you create that model, ExOne doesn't have a problem with the repeatability of their process.
But the fact is, a lot of jobs there's a million jobs out there at different foundries that were made before 3D modeling was used, and they were done the old-fashioned way by machining out the shell box. And
yeah.
So it has to be done properly before, and that's one of the obstacles of getting printing done. But I can see that definitely this could be used, on a lot of different stuff for the foundry, for valves especially.
Right, on legacy jobs that have been around for quite a while. As Greg mentioned, there probably isn't a CAD model out there. So depending on the complexity of it and your company's ability to create that, that's something you need to consider. Moving ahead, more and more, I mean, the pattern makers are are a dying breed. Now you have machine operators that work off CAD models. So the new part numbers going down the road will pretty much all have CAD models. So now it's just a key of adding those core prints and other chaplet pads if you have such, and so on. So.
Okay, well, thank you very much, Terry, Bob, and Greg, and thank you to all the attendees for joining us today. Be sure to be checking your inboxes in the next day or so for the recording of today's webinar. But again, thank you all.
Thank you.
Thank you.
Thanks.